All right, now we're reviewing difference of squares. Difference of squares factoring was a certain type. Let's look at what it says. Difference means subtracting. Squares mean that you need to have numbers that are squares. So what I mean by that is, for example, 3 squared is 9. 9 is a perfect square. 4 squared is 16. That's a perfect square. 2 squared, let's back up real quick, is 4. 1 squared is 1, and so on. 5 squared is 25. 6 squared is 36. So perfect squares. So when we see this, we're looking for it to be a binomial, meaning 2 terms. This says 2 terms right here. This is a binomial. It is subtracting. And I know I can square root x squared, and I know I can square root 16. So the format for difference of squares, what it is if you have 2 numbers that are perfect squares and they're subtracting, you can take the square root of the first number, the square root of the second number, and one parenthesis has a plus and the other has a minus. So on this one, it's x squared and 16. The square root of x squared is x. The square root of 16 is 4. So you have one factor is x plus 4. And then you still have the square root of x squared and the square root of 16, still x and 4. But the other one is minus. So it's x plus 4 times x minus 4. So those are the 2 factors. That's the difference of squares. So like on this one, it's a binomial. So that's good. 2 terms. That's what we're talking about when we say binomial. It is subtracting. That's difference. And I can square root 49x squared and I can square root 100. So I know this is a difference of squares pattern. So the square root of 49 is 7. Square root of x squared is x. The square root of 100 is 10. So both factors are going to have 7x and 10. One will be 7x plus 10. One will be 7x minus 10. And it does not actually matter which one you pick first. You could do the 7x minus 10 first and then the 7x plus 10. It makes no difference. Okay, so then on this one, we have a difference of squares. So it's subtraction. It's 2 things, so a binomial. And then this isn't a square root. I can't square root 3. And I can't square root 27. I can, they're just decimals. So they're not nice, perfect squares. So what I'm going to look at doing is see if there's a GCF. The GCF between 3 and 27 is 3. What I mean by that is they are both divisible by 3. So I'm going to divide by 3, and I get x squared minus 9. Now, x squared minus 9 is a difference of squares. It's 2 terms, then you can square root both. The square root of x squared is x, the square root of 9 is 3. And so you have that, and one is x plus 3, one is x minus 3. And don't forget to write this 3 in the front, because when you pulled out the GCF, you can't just leave it off. It still needs to be written in the front.